Welcome back to my channel, everyone. 3 tips here. What I have is a little Dino light digital microscope, and if you look over here you'll be able to see an image on my computer screen there of me wiggling my fingers under the scope. And what we're going to do is I've got some Inquarted gold here that has been parted with hot dilute nitric acid. And I've never really taken the time to look at this stuff before. I usually just throw it in some aqua regia and refine it. So today we're going to look at this and maybe even bust a piece open and see if we can observe the honeycomb structure that happens inside these pieces of Inquarted gold when we do the nitric acid boils. This Inquarted gold has had the silver alloyed with it to reduce the carat down to 6K or down to 25% pure gold. And the reason we do that is so that the nitric boils can penetrate to the core of each of these pieces in here and remove all of the silver and all of the base metals that are in this alloy. And if we did not do that, like say for example, and I've done this before on a video, this is my 14K wetting band. If we throw the 14K wetting band into the boiling nitric acid, nothing happens. It just sits there. And that's because the high carat of the gold, the high gold content in the alloy, 14K is about almost 60% pure gold, with the rest being copper, zinc, and silver. But if we threw this ring into a vat of boiling nitric acid, nothing would happen. It would just sit there. It's only when we take an alloy additional sterling silver with the carat gold, then and only then will the nitric acid boils be able to penetrate to the core of each piece and remove all of the silver and all of the base metals. Like I said, I rarely take the opportunity to look at this stuff before I refine it. And if you look right there, there's a little piece of something in there. Let's see if I can fish that out with a pair of tweezers. This might be tricky. It looks like a piece of gemstone that is broken. I'm not quite sure what it is. I'm not going to mess with it. I'm not able to get in there and get it conveniently. But what we're going to do is I'm going to pull out one of these chunks of gold here. See if I can get this out of the way without making a mess. This is one of our chunks of Inquarted gold. And what I want to do now is I'm going to put it in this little dish. And what we'll do is we're going to break this thing open and look at it and see if we can observe the honeycomb structure that gets formed as the hot dilute nitric acid boils penetrate to the core of each of these pieces of Inquarted gold. Alrighty, I've got the microscope zoomed in on it, and I've got it recording. And now what we're going to attempt to do here, carefully, is see if we can break this open and look inside and see what it looks like down inside of the piece of Inquarted gold after the nitric acid boil. And I don't really see a whole lot of structure going on in there. It looks just like a piece of Inquarted gold that has been treated with nitric acid. Alright, I couldn't see much on the microscope there. I'm going to try to lean this piece up against another piece. And let's see if we can get a better shot, a closer shot of what's going on inside of this Inquarted gold. Alright, I've got the microscope right down on it, and I've got it focused as high as it will go. And I really don't see any kind of honeycomb structure that is said to exist when we do this nitric acid boil. It just looks like a flat piece, similar to what the outside of the piece looks like. And I'm thinking maybe that's due to the fact that it's wet, and the fluid is going to fill in any kind of pock marks or honeycomb structure that we might be able to see. So anyway, we looked at it. Maybe I could try drying this out and then re-examining it, and maybe that's what we'll do. Let's try that next. I've got the Inquarted gold in this little dish here. I've broken it in two and leaned it up on its side. So now what we're going to do is I'm going to put it in this dish for convenience. And now what we'll do is move this up. We'll put it on a little bit of low heat here. We're going to try to dry out our piece of Inquarted gold, and then put it back under the microscope and see if we can observe the honeycomb structure that's said to form inside the piece of Inquarted gold. While I'm waiting for this piece of gold to dry out, take a look at this beaker here. It's full of cement silver that has cemented out onto a piece of copper pipe that I have in there. And I've been adding silver nitrate solutions to this beaker to continue to cement the silver out of the solution. I'm going to get in here now, and I'm going to stick my rod in here. I'm going to stir this up. And there's my copper that I'm using to cement the silver out of the solution. And then down here is our silver that's falling to the bottom of the beaker. It's been allowed to dry completely. Now let's go in and see what we can see under the microscope. We give it our best shot to try to see what we could see under this crude microscope that I have here. I don't think it was powerful enough to display the honeycomb structure that we were looking for. That's quite all right. Now what we're going to do is take this material, add it back to the main beaker over here. And now what we'll do is go out and refine this gold into a nice pure gold bar. Here's our Inquarted gold that's been treated with 6 hot dilute nitric treatments. What I'm going to do now is add it to this large beaker. Now let's get the water out of there. It's going to pour it off into this beaker that we had initially. It's going to pour the water off to get it off the gold. And now what we'll do is we're going to add hydrochloric acid. Hydrochloric acid to this gold. It's about a little over 3.5 troy ounces, so we're going to go with, going to fill it up to about the 400 milliliter level. Now I'm going to add about a 0.5 milliliter of sulfuric acid to precipitate out any lead that may be present in this gold. I'm going to measure out about 40 milliliters of nitric acid. 40 milliliters nitric acid. And we're going to add this right on in to our gold and hydrochloric acid mixture. Form aqua regia in there. We're going to cover this up now, and we're going to stick it up on our heat in the back and dissolve our gold in that aqua regia. We've got just a few crumbs of gold down here on the bottom of the beaker. Our solution is nice and hot, boiling vigorously. What I'm going to do is add a little bit of nitric acid now to try to get these last few crumbs of gold to go into solution. Now this is going to flare way up with just a few drops of nitric. That was about 3 drops of nitric right there. Because it's so hot, so we got to add the nitric acid very slowly. And what we're doing here is just adding the right exact amount of nitric acid to get the rest of this gold to go in solution. And if we do this correctly, there will be no excess nitric that will have to be neutralized before we go to the next step, which is the precipitation after we filter. All the gold has gone into solution now. Might have a few little pieces left down here. So what I'll do is I'm going to pull this down off the heat. I'm going to let this cool down. I'm going to add some ice to cool this down and to precipitate out any silver chloride that might be present. Now what we're going to do is fill our ice tray back up with some distilled water, and we're going to put it into our freezer and make some more ice cubes out of distilled water. I do this normally over the sink. I'm making a mess over here, but it's just water and it'll dry up. Stick it up here in our freezer, and then the next time we need frozen water for our refining processes, we'll have some nice ice cubes made from distilled water. Our solution's cooled down to about the temperature of a glass of cold iced tea. Now what we'll do is we're going to filter the gold here. It's got a slight bit of cloudiness to it, but not too bad. So we're going to filter it now through this filter paper. You can see here how clear the solution's looking. Getting the solids filtered out up here. This is a real good filter. I like these filters. It's a number 2 medium flow. And this is what the original solution looked like compared to the filtered solution. You can see we got a nice filtrate flowing in there, nice and clear now. I'm adding the rest of the dissolved gold to our filter now. If you look down the bottom of the funnel, or the bottom of the beaker rather, you'll see we got those chunks of white material. Not quite sure what that is. And there it is. I don't know what that is. Can't identify it. There's our filter. I've got everything rinsed out now. You can see the filtrate coming out of the bottom of the funnel there is clear and colorless. It's just water. And our solution did not form any kind of precipitate down here. And that's a good sign for high purity. Got a clean beaker with some ice in it. We're going to transfer our solution into this beaker now. Notice how clear it is. That's a tip off that we've got some high purity gold with just this single refining, which is a good thing. I'm going to check it with stannous chloride before we do the precipitation. I mean, I know there's gold in here, but for the sake of being thorough, I'm going to check it with some stannous. There you go, a nice dark stain, golden solution. Here we go. We're going to use some Stump Out by Bonide, which is sodium metabisulfite. We're going to precipitate out the pure gold now. Here goes the first spoon right now. Two. 3. 4. 5. See that head of foam forming on the top there? That's a tip off that we've got all the gold precipitated out. Yeah, there's a nice head of foam right there. I'm gonna stir it up. Now let's do another stannous test, verify that we've got all of the gold precipitated out of our solution. I'm going to dip this piece of filter paper down in there. And you can see no reaction on the piece of filter paper with the stannous chloride testing solution. Means we've got all of the gold precipitated out of this solution. We've allowed the gold solution to settle for about an hour now. I'm going to pour this off into a waste container. The solution I'm pouring off is a waste solution. Wow, the gold looks really good down in there. Now we're going to rinse with a little water. Now I'll pour this off to our waste container. Quick rinse in hydrochloric acid. Now a quick rinse in a little bit more water. Now I'm going to put in about half a liter of hydrochloric acid. I'm going to set this back up on the heat and redissolve it a second time. Put in a small amount of sulfuric acid to remove any lead that might have made it this far. I always add sulfuric acid whether I suspect the presence of lead or not. Now I'll measure out some nitric acid here. Let's see, I'm going to use probably about 45 milliliters, I guess. And we're going to pour this right on in. Cover it up and add some heat. I've just added the nitric acid. Here you can see those two acids combine to form aqua regia, and our gold immediately begins to dissolve and go into solution. Gold will dissolve in those two acids just like sugar dissolves in water. Here I'm preparing a new melt dish, driving off the moisture with the heat. Then I take tiny pinches of borax and I go around the rim, turning the dish as I go, and coat the entire dish with borax glass. And this will prevent the gold from sticking to the melt dish. Here's our properly glazed melt dish. It's got a thin coating of borax all over it. And borax does not burn. When we heat it, it melts. I'm sure at some point it would combust, but we don't get it hot enough to burn. We just get it hot enough to melt. And then it coats the inside of our melt dish. And then the gold or whatever metal we're trying to melt in here won't stick to it. If you look down in the bottom of the beaker there, we've got just a couple of small pieces of gold that have not gone into solution. So what this tells me is that we've added the correct amount of nitric thus far to just get that gold dissolved. Notice that there are no fumes in there. The atmosphere inside the beaker is clear and colorless. So what we're going to do, I've got some nitric acid. I'm going to put just less than a half a milliliter into the beaker here and try to get the rest of this gold to dissolve. Drop it in a few drops at a time, and you'll see it reacts fairly vigorously, and this should be enough to get our gold to go in solution, that last little bit. What this does for us is it guarantees that we won't have any excess nitric in there to deal with when we go to do the precipitation. There's no need to add any kind of reagent to kill the excess nitric because there is no excess nitric to kill. We've got everything dissolved. We're going to cut the heat off, pull it down off the heat, and let this cool down. Got some ice here made from distilled water. We'll cool our solution off with some ice made from distilled water. Now we're going to filter our solution. Notice that it's crystal clear and free of any cloudiness. Got all the liquid pulled through the filter. Now we're going to rinse all the color out of it. Still a few particles of gold left that didn't dissolve, and that's quite all right. That means we've got all that excess nitric completely consumed in that solution. Let's see if we can do this all in one take. Get the filter funnel out of here. Now I've got a beaker that's full of ice. We're going to transfer our solution into this clean beaker with ice in it. Here we go. We're going to add some stump out now. Stump out is sodium metabisulfite. Bought this at the hardware store. Go ahead and put a spoon of this in now and start precipitating our gold out a second time. There's our white foam on top. We're almost there. One more. So that was 9 spoons to get our white foam. I think we got everything precipitated now. Allowed the gold to settle for about an hour. It's settled completely. There's something following the gold, but that's quite all right. We're just going to pour off this waste solution now. That redness in that liquid is some kind of contamination. Now I'll rinse it with some water. Pour this off now. Now we'll give it a rinse with some hydrochloric acid. Another rinse with some more water. I'm going to add some hydrochloric acid. And we're going to set this up on the fire now and do a quick boil in hydrochloric acid. It's been boiling in hydrochloric acid now for about 10 minutes. And what we'll do now is take this liquid, pour it off into our waste container up here. Oh yeah, it's looking real good. I'll rinse it with some water. Pour that off. Here's a look at the gold down in our beaker. It's looking very, very good. Let's get the gold into this freshly prepared melt dish. I will take it over to the melt table. I'm going to melt this up into a nice gold bar. Here's our bar of pure gold that we just refined. Look at that thing, man. It's just absolutely beautiful. I never cease to be amazed by how beautiful pure gold is. There's nothing like the look and feel of pure gold in the palm of your hand. Let's see what we got for a weight. I was expecting 119.1. We got 116.7 grams. That's 3.75 troy ounces of pure gold. Gorgeous, beautiful. Wish I could keep it, but this is getting sent in today. I got more debt that I have to pay, so I'm sending this into the big refiner today. All right, that'll conclude the video. Thanks for watching.